Welcome to Beta Online Learning, and this is a video for the 8th standard CBSE mathematics on the topic mensuration, part 1. In this part 1 of the video, we will show you the area of quadrilaterals, area of polygons, and trapezium. First of all, we will see what is the area of quadrilateral, a four-sided figure. We have 4 sides. A polygon is a n-sided figure, having n sides, any number of sides. We can divide it into basic shapes. In this, we are going to see the area of a quadrilateral is a four-sided figure. So you can see this quadrilateral, this figure. ABCD is a quadrilateral having 4 sides, AB, BC, CD, and DA. These are the 4 sides. To find the area of this quadrilateral, we divide this quadrilateral into 2 triangles. We know that the area of a triangle is equal to half base into height. So if you divide this, let us draw a diagonal BD, one of the diagonals. Let us draw this diagonal BD. We know that this diagonal divides this quadrilateral into 2 triangles. What are the 2 triangles in this quadrilateral now? The triangle ABD, BAD, or ABD, this one triangle, and another triangle BCD or CBD. ABD and CBD are the 2 triangles. The base of each of these triangles is BD. It's a common base here. BD. And it is area of triangle ABD is, what is the area of triangle ABD? It is the base BD half into BD into the height is the altitude, which is AE here. What happens here is we have drawn 2 perpendiculars from the vertices A and C respectively, AE and CF, and BD from the vertices A and C respectively, AE and CF. So half base, half BD into AE plus half BD into CF. We have taken half BD as a common factor outside, and we have put AE and AE plus CF within the brackets. So this is the area of the quadrilateral, half BD, half into BD into AE plus CF. Next, we see the trapezium. Area of a trapezium. What is a trapezium first? Trapezium is a quadrilateral having one pair of opposite sides as parallel and the other pair of opposite sides non-parallel. Here, we have drawn a trapezium here. ABCD is a trapezium. AB is parallel to CD. You can see AB, the side AB is parallel to C. Opposite sides AD and BC are not parallel. They are the non-parallel sides of the trapezium. And we have here AB. Is parallel to CD. So what will be the area of this trapezium? It is given by the formula. Area of trapezium is half into CE into, and what is CE now? CE is the perpendicular drawn from the vertex C to the side BAB, the parallel side AB. It is nothing but the CE is nothing but the distance between the 2 parallel sides AB and CD. So here again, it is given by half CE into AB plus CD, the sum of the parallel sides. So we can write that half into distance between the parallel sides or the heights. This is the part 1 of this video where we are going to see the area of quadrilaterals, polygons. We will take some basic shapes like here. The expression is half h into a plus b. That is what is given here. The h is the height, and a, small a, letter a denotes one of the parallel sides, and small letter b denotes the other parallel side. In the textbook it is given there. I'm just going through this. Let us find out, first of all, let's take it as area of the trapeziums. These are the two questions here. Let us work out this. See, actually this, it is given in figure 1, subdivision 1 of this question. Area of the trapezium having the parallel sides is 9 centimeter and 7 centimeter. The height or the distance between the two parallel sides is given as 3 centimeter. Here, 3 centimeter. So, half into 9 plus 7, which is equal to 16, 9 plus 7, into 3. So, 1 by 2, if we work it out, it is 1 by 2 into 16. 1 by 2 into 16, which is 9 plus 7, into 3. Mind itself we can work out. Half into 16 is 8, 8 into 3, 24. Or half into 48. 16 into 3 is 48. Half into 48 is equal to 24 square centimeter. 24 centimeter square is the answer for the first one. You could work out the next one. You could note down this. This is actually the parallel sides, 5 centimeter and 10 centimeter. 6 centimeters the distance between the two parallel sides. That is the height of the trapezium. We think the trapezium is rotated. That's all we can say. Now let us move on to this general quadrilateral. Already we have seen that in that figure. Half the two heights. Here we have taken this diagonal AC and the two heights H1 and H2. So in general, half D, any quadrilateral, half into diagonal into the sum of the two altitudes on the diagonal from the opposite vertices. That is all. The other two opposite vertices. So here the example 1 is given there. We can see this. PQRS is a quadrilateral and we have QS is the diagonal. So half into QS, which is 5.5 centimeter here, D, that is the diagonal. H1 and H2 are the two altitudes on the same diagonal from the two opposite vertices, the other two opposite vertices, P and R. We get 1.5. So we have half into 5.5 into, within brackets, we have 2.5, the sum of the altitudes, H1 plus H2. And it works out to 4 centimeter. 5.5 into 4 is actually, you will get actually 22, half of 22 is 11 centimeter square. A parallelogram is also a quadrilateral. We know that the parallelogram, the area of a parallelogram, already in 7th you have learned that it is base into height. That's all. Base into altitude. The area of a rhombus In fact, rhombus has a special quadrilateral. It has a rhombus is a parallelogram in which all the sides are equal and the diagonals bisect each other at right angles. It is very simple. The area of a rhombus is half into the product of the two diagonals, AC and BD, D1 into D2, half into D1 into D2. That's all. If you are given the sides, you have to find the, if you're given one side and one of given one diagonal or something like that, we can find out. The Pythagorean theorem is here. We can find out the other diagonal, the length of the other diagonal, half of the diagonals, and then we can find out easily this one. You see some examples here. There, directly the diagonals are given. In example 2, diagonals 10 and 8.2 are given directly, so we can directly substitute in that formula half into D1 into D2 and find the area of the rhombus. Here are some of the figures in the book. You have to try them out. Area of these quadrilaterals. What do we say about the first figure? It's a quadrilateral, general quadrilateral. 6 centimeters the length of the diagonal. So what would be the area of this ABCD quadrilateral? The heights are given 3 centimeter and 5 centimeter on AC, on one of its diagonals, AC. So half into 6 into 3 plus 5. That's all. 8. 6 into 8. 6 8 are 48. Half into 24 centimeters square. That's all. What about this rhombus? It is given, the diagonals are given only, I think here 4 centimeters. So 7 centimeter one diagonal and the other one diagonal is 6 centimeter. So you can easily find out the area. Okay. Now let us move on to polygons. When polygons are given, you have to divide it into two trapezia, two quadrilaterals. Actually, you have to divide into one triangle and a quadrilateral and then find the area of this one. This actually, we need some construction required here. We divide polygons into two figures. One is a quadrilateral and the other one is a triangle, irregular polygons. Area of the triangle and area of a trapezium. Area of a triangle is half base into height. Area of the trapezium you can find out by half h into a plus b. That way we can find out. Trapezium, there are, in this thing, there are 3 sections. One is the triangle ADE, figure 11.18 here. ADE is one triangle, half base into height. You will find that the remaining part of the polygon is a quadrilateral in which one part is a trapezium. We have drawn perpendiculars BF and CH, which become this BFHC is a trapezium. The two parallel sides are BF and CH. And the other two non-parallel sides are BC and FH. So we can find out, if you are given the sides, we can find out. And we have another 2 triangles, right angle triangles, whose area we can find out. I have to add all these together. In this figure, we have a polygon. This polygon has how many sides? M, N, O, P, Q, R, M. Q, R, that's all. Again, we come to M. MNOPQR. 1, 2, 3, 4, 5, 6 sides. So it is a hexagon, but it's not a regular hexagon. So to find the area of a regular, non-regular, or any polygon having unequal sides, which is not a regular polygon, it's a hexagon, that's all. So it has different parts now. We have divided it into different sections like this. We have drawn altitudes. There are here mostly the heights will be given. The altitudes here, the 2.5 centimeters. So that becomes a trapezium now. This part ACON becomes a trapezium because there are two parallel sides. These two perpendiculars are actually parallel sides. You know, there is one theorem or one property that perpendiculars to the same straight line are parallel to each other. It's a very important basic thing. Thereby, perpendiculars to the same line, MP. See, MP is a perpendicular, MP is a line segment, and we have drawn perpendiculars from different points. Say, NA is a perpendicular to the same line PM, and OC is another perpendicular drawn to the same line MP. So these two lines AN and OC will become parallel. They are indeed parallel to each other. This is one important property of a perpendicular lines. So it becomes a trapezium here, area of this trapezium. So this trapezium, we don't need the sum of the non-parallel sides. We need only the measure of the parallel sides and the distance between the two parallel sides. The distance between the two parallel sides here, AC is required. The AC is required here. We are given MP. See, we are given MP. Looks complicated, but it's quite easy if you go into the figure. MP, the entire figure is given as MP is 9 centimeter. MD is 7 centimeter. So we can say here MC is also given. MC is also given. MB is also given. MB, what is MB? Here is a part of it. So to calculate this AD is what we need now. Yeah, sorry, AC. We need AD, AC and BD here to find the area of these two trapeziums. These two trapeziums, if we find out, then since MB is given, that is a right angle triangle. This part is a right angle triangle. We can find out the area of the right angle triangle. Half into base into height. See, the two lines are perpendicular to each other, so we can easily find out. So this is one part of it. Okay. This is another triangle. So it add all these two triangles, two right angle triangles, and one trapezium. So what we need, first we find out. What we need here, BD we need, and also we need this one. We are already given 2.5 and 2 centimeter. The two parallel sides of the trapezium. We consider only the trapezium BDQR. This trapezium. Each trapezium we take separately. Since the lengths are given, we have to find BD. Because that is the distance between the two parallel sides or the height of the trapezium. BD can easily be found out from the measurements given. We know the entire length MP, 9 centimeter. We know MD also. We know MC. See, actually BD is nothing but the whole length MB, MP minus the sum of MB and DP. We know MB. MB is already given. MB, 4 centimeter. So if we subtract 4 centimeter, subtract MB from MP, we will get that BP. But we have to subtract DP. How to find DP is the problem. The problem is DP. DP is actually the whole MP minus MD. Very simple. The whole MD is MP minus the MD. MD is given 7 centimeter. 9 minus 7, the DP is 2 centimeter. You got it? 2 centimeter. DP is 2, is PD, the DP. So it is 2 centimeter, and thereby when we subtract the whole 9 centimeter minus of this one, minus of MB is already given 4 centimeter plus this 2 centimeter DP, which we have now found out, the 2 centimeter. So 4 plus 2, 6. 9 minus 6 is 3. So BD is 3 centimeter. We easily found out. Hence, the area of the trapezium we can find. You have to work it out. Okay. Let us now move on to the other things. It's a worksheet type of thing. The exercise questions. Exercise questions, easily you can work out. I will just go through the first question of this exercise. This exercise happens to be the first exercise for the new books. We have the old book here, the new textbook, new NCERT book. You have 9.1, I think. You can just refer to it, your textbook, the trapezium. You can work out this. We are given the sum of the path. It's just the area of the table. That's all. Perpendicular distance is given 0.8. It will be 1 by 2 into h 0.8 into 1 plus 1.2. That's it. Calculate it. This exercise is okay. This is how you have to do this exercise. Let's just take this part and just work out. I'll just take the dimensions of that table question. The table question is a trapezium. It is half into. So we have here the area of the table is half into 0.8 is, you already know, that is the distance between the two parallel sides, or the height. 0.8, and we have 1 and 1.2. One side is given as 1.2 centimeters, and the other one is 1. And the other one is 1. So we can substitute these values here and then get the value of here. So it is half of 0.8 is 0.4 into 0.4. This should be, there is a decimal point there. And we have a multiplication. Oh, it's not 0.4. It's 0.4 multiplied by 3.2, 2.2, because 1 plus 1.2 is 2.2. 2.2, which is equal to 8. You will get, if you ignore the decimal points, we get 88. 4 into 22 is 88, but we have 2 decimal places. We have 2 places. One is 0.4 0.4 and the other one is 0.2. So you will get 0.88 meter square. You can put it as meter square here because the dimensions are given in meters, and this will be the answer for the first question. You understood? Okay, now we can complete the rest of the questions in that exercise. I'll share it again for your, just a minute. I will put this. Here it is. So we have 0.8 to 1.2 plus 1 is equal to 0.8 becomes 0.4, half of 0.8. You add these two, you get 2.2, and on multiplication we get 0.88 in meter square, the area of the table top. This is the answer for the first question. I'll just get it done for you. Just a minute. Here it is. So, and after that, we have this is the tabletop problem. So we have come to the end of the part 1 of this video. This part 1 of the series of videos on mensuration. First of all, we have taken in this video, we have seen the area of general quadrilateral, polygons, and of trapezium. Main thing is area of trapezium, and the area of a quadrilateral, area of special type of quadrilateral, like area of rhombus. Area of rhombus is, what is the area of rhombus? The area of rhombus is half into product of its diagonals. That's all. Area of a quadrilateral, once again, we just see that one. Just a minute. Area of a quadrilateral we will get it back. This is the area of the quadrilateral. Trapezium, general quadrilateral. This is the figure. And the area of a trapezium with its formula. So we saw these mainly these two things in this part. In the second part, we'll go through the other second exercise questions. You try to complete this exercise, first exercise, 9.1. And here now we end this session. And we have seen today mensuration, on the topic mensuration, the area of quadrilaterals, polygons, and trapezium.